Have you ever walked past a steam grate on a freezing January night and noticed the heat rising through the metal, warming a small circle of sidewalk while everything around it stayed frozen? Somewhere beneath that grate, beneath the streets you drive on every morning, there are people who have built entire lives underground, not because they chose darkness, but because the world above stopped making room for them. Every winter in America, approximately 700 homeless people die from hypothermia. Their average life expectancy hovers around 50 years, nearly 2 decades shorter than housed Americans. But the ones who survive, the ones who make it through nights when temperatures plunge below zero, they do it with an ingenuity that would humble most engineers. Today, we're exploring how homeless people build underground shelters to survive winter, and the resourcefulness behind these structures will change how you see every storm drain, every abandoned tunnel, and every patch of disturbed earth you've ever walked past without noticing. Let's start with choosing the right location. Nothing matters more than where you dig, and experienced homeless builders have developed an instinct for reading terrain the way a farmer reads soil. South-facing hillsides are prized because they catch whatever winter sun exists, warming the earth even when air temperatures drop below freezing. Spots near tree lines provide natural wind barriers that can reduce wind chill by 10 degrees or more without any construction at all. The ground itself tells you what it can offer. Clay soil holds structure and won't collapse during rain. Sandy soil drains well but crumbles without reinforcement. Experienced builders avoid low-lying areas where cold air pools at night, creating frost pockets that can drop temperatures 5 to 10 degrees colder than surrounding ground. They also stay clear of floodplains and drainage paths because a shelter that fills with water during a February thaw becomes a death trap. The veterans, the ones who have survived multiple winters underground, choose spots near infrastructure that radiates residual heat. Steam pipes, subway ventilation shafts, and building foundations all emit warmth that can raise the ambient temperature of a nearby dugout by several critical degrees. Digging below the frost line is the principle that separates a shelter that saves your life from a hole that just delays the cold. Below approximately 4 feet of earth in most northern climates, the ground maintains a stable temperature between 50 and 55 degrees Fahrenheit year-round, regardless of what the air above is doing. That means a shelter dug deep enough sits in a natural thermal envelope that stays above freezing, even when the surface plunges to 20 below zero. Homeless builders who understand this principle create spaces that require almost no supplemental heat to remain survivable. The digging itself is brutal work, especially in frozen ground where the top layer might be solid as concrete. Some use salvaged garden tools. Others work with sharpened pieces of rebar or flat stones lashed to sticks. The work happens in stages across days or weeks, with builders covering their progress each morning to avoid detection. Every shovel of earth removed represents hours of labor performed by hands that are often already cracked and bleeding from the cold. Reinforcing walls and preventing cave-ins becomes the next critical challenge once the digging reaches depth. Bare earth walls in a rectangular excavation will eventually collapse inward, especially when rain or snowmelt saturates the surrounding soil. Builders have learned to use salvaged wooden pallets as wall reinforcement, standing them vertically against the earth and bracing them with horizontal supports. Plywood sheets scavenged from construction dumpsters provide smoother wall surfaces that also reflect body heat back into the living space. Some builders pack the gaps between wood and earth with plastic shopping bags filled with dry leaves, creating insulation pockets that trap air and slow heat transfer through the walls. The most experienced underground builders know to angle their walls slightly outward from bottom to top, creating a subtle wedge shape that distributes the pressure of surrounding earth more evenly and dramatically reduces the risk of sudden collapse during freeze and thaw cycles that shift soil throughout winter. Constructing the roof is where the real engineering reveals itself. The roof must bear the weight of accumulated snow, shed rain without leaking, provide insulation against heat loss, and remain inconspicuous enough to avoid detection from above. Builders typically lay thick branches or salvaged lumber across the top of the excavation, spacing them close enough to support the layers above. Over this framework, heavy-duty tarps are stretched tight and secured with rocks or stakes driven into the surrounding earth. On top of the tarp goes the critical insulation layer. Dry leaves, pine boughs, moss, and earth are piled 12 to 18 inches thick, creating a barrier that traps warm air inside while keeping frigid air out. In heavy snow regions, builders allow snow to accumulate on top of their shelters rather than clearing it, because a 2-foot layer of packed snow provides insulation equivalent to 6 inches of fiberglass. The roof is often the most carefully maintained part of the structure. Check daily for sagging, leaks, or signs of structural weakness that could mean catastrophic failure in the middle of the night. Creating a proper entrance requires understanding how cold air behaves. Cold air sinks, which means a straight, level entrance becomes a highway for freezing air to pour directly into the living space. Experienced builders construct their entrances at angles, sometimes with a downward step, followed by an upward step into the main chamber. This creates a cold air trap where the heaviest, coldest air settles into the low point and never reaches the sleeping area above. Some add curtains made from layered plastic sheeting or heavy blankets at the entrance, creating an airlock effect that further prevents heat loss. The entrance typically faces away from prevailing winter winds, which in most of the northern United States blow from the northwest. Veterans of underground living can tell you the wind direction of their area without hesitating, because that knowledge has kept them alive through nights that killed others who built carelessly. Insulating the floor and sleeping platform is what separates uncomfortable survival from something approaching actual rest. Direct contact with cold ground drains body heat faster than cold air does, a principle that hypothermia researchers have documented extensively. Builders elevate their sleeping areas using stacked pallets, creating an air gap between their bodies and the earth below. On top of the pallets go layers of cardboard, which provides surprising insulation due to its corrugated structure, trapping air in tiny channels. Foam padding salvaged from discarded mattresses or packing materials adds another layer. Then come blankets, sleeping bags, and whatever fabric can be gathered. Some builders stuff dry newspaper into plastic bags to create makeshift pillows and mattress pads, knowing that the trapped air inside the crumpled paper holds warmth the way goose down does in expensive sleeping bags. The most resourceful builders collect fallen autumn leaves by the garbage bag full, storing them in dry spaces throughout the shelter and packing them around their sleeping areas like natural insulation that costs nothing and works remarkably well. Heating these underground spaces requires extreme caution because ventilation determines whether a heat source provides comfort or produces carbon monoxide that kills silently in enclosed spaces. Small candles placed inside coffee cans generate measurable warmth in a confined underground room, raising temperatures by 5 to 10 degrees while also providing light during the 16 hours of winter darkness. Some builders construct tiny stoves from stacked cans with ventilation holes punched through, burning small amounts of wood or alcohol fuel with a chimney pipe vented through the roof. The chimney must exit the shelter and rise above the surface to draw properly. And builders often disguise it with branches or debris to prevent detection. Body heat alone in a properly insulated underground chamber can maintain temperatures above freezing. 2 people sharing a well-built shelter can keep the interior above 40 degrees simply by being present, their combined metabolic output doing what furnaces do in homes above them. Waterproofing against snowmelt and groundwater consumes constant attention throughout winter. Builders line floors with overlapping layers of plastic sheeting, running the edges up the walls to create a continuous moisture barrier. Drainage channels are sometimes carved into the floor, directing any water that penetrates toward a low point near the entrance where it can be absorbed or baled. The tarp roof layer must remain intact and properly sloped because a single tier can allow snowmelt to seep through the insulation layer and soak everything below. Experienced builders keep repair materials on hand at all times, patching holes with duct tape, additional plastic, or even melted candle wax in emergencies. Dampness is the silent enemy that kills more efficiently than cold alone, because wet clothing and bedding lose their insulating properties and accelerate the body's heat loss to lethal rates. Building community underground has produced some of the most remarkable hidden societies in American history. Beneath New York City, the Freedom Tunnel, an abandoned Amtrak passage running under Riverside Park from 72nd to 120th Street, housed up to 100 residents during the late 1980s and early 1990s. These people built shanties with electricity tapped from nearby junction boxes, created communal cooking areas, and maintained social structures where experienced members guided newcomers through the challenges of tunnel living. Beneath Las Vegas, an estimated 300 to 1,500 people inhabit over 200 miles of storm-drained tunnels, creating furnished living spaces with salvaged mattresses, bookshelves made from milk crates, and careful systems for hoisting belongings above floor level to survive the flash floods that represent the tunnel's greatest danger. These communities develop their own cultures, their own rules, and their own ways of caring for one another in darkness that the world above rarely acknowledges. Camouflaging the shelter from detection is a survival skill in itself, because discovery usually means destruction. Builders scatter natural debris across the roof surface so it blends with the surrounding landscape. Entrances are concealed behind brush piles, fallen logs, or constructed barriers that look like natural accumulations of forest debris. Some builders approach their shelters using different paths, each time to avoid creating a visible trail through snow or vegetation that would lead directly to their door. The most careful builders limit visible signs of habitation at the surface level entirely, carrying waste out and disposing of it elsewhere, never building fires near the entrance where smoke or scorch marks could attract attention. This invisible discipline comes from hard experience. Many have lost shelters they spent weeks building to a single moment of carelessness that brought authorities or hostile strangers to their hidden doorstep. Storing food and water underground takes advantage of the same stable temperatures that make the shelter livable. Below the frost line, food stays cool enough to prevent spoilage, but warm enough to avoid freezing solid. Builders stockpile canned goods, dried foods, and sealed water containers in their shelters throughout autumn, preparing for weeks when heavy snow or extreme cold makes surface travel dangerous. Water is collected from snowmelt when possible, filtered through improvised systems of cloth and charcoal, and stored in whatever clean containers can be salvaged. Some builders near urban areas maintain relationships with soup kitchens, shelters, and charitable organizations, traveling to the surface for hot meals on days when weather permits, then retreating underground with whatever supplies they can carry back. Surviving the psychological weight of winter underground may be the greatest challenge of all. Extended darkness, isolation, and the constant awareness that one structural failure or one flash flood could end everything creates a mental burden that no amount of physical preparation can fully address. Those who make it through winter after winter develop a quiet resilience that comes from knowing they have faced the worst the world can deliver and found a way to continue. They share knowledge with newcomers, teaching the skills that kept them alive so that others might survive too. The shelters themselves become testaments to human determination. Each reinforced wall and carefully angled entrance representing a refusal to surrender to circumstances that were never chosen. These underground builders carry knowledge that survival schools charge thousands to teach, learned not from textbooks but from necessity on the coldest nights of their lives. Their shelters may be invisible to the world above, but they represent some of the most remarkable acts of human engineering happening in any American city right now, built by hands that most people never see, in places most people will never look. Thanks for joining us on this journey beneath the surface. If this changed how you think about what it takes to survive when the world stops making room, share this with someone who needs to see it. Hit that like button and subscribe so you never miss another story about the resilience hiding in plain sight.